Hey, I want to talk a little bit about adhesion, that stuff that sticks together. Saw a really fantastic presentation. This is Foster Lyons content that he presented, and I'm bringing it to you here with slightly better graphics using AI because Foster's graphics weren't great. Sorry, buddy. All right, so here we go. First, everything is sticky at an atomic level. Everything wants to be stuck together when it gets very, very close. Electromagnetic force is 10 to the 36th power after all, which is the power of the universe. Close. But we're not at the atomic level. Okay, so now what? Well, we have intermingling. Intermingling, think about nails. When you nail a board together to make a beam, all right, you've got all these nails going through it. If you were to take a cross section and you see those nails, that's intermingling. Entanglement. Entanglement, think of that drawer that you have with all of those cords in it that are all tangled. You pull on one, they all come with it. That's entanglement. Okay, so how about some real world examples? So let's start with the surface bond. Two things being very close to each other. There's a thing called a butt pull. Two metal blocks that are very, very, very smooth. There's very little between them. And it can withstand 70,000 pounds force per square foot in one direction. Very hard to pull apart. But in another direction, very easy to break. So it's not very useful for us when we're talking about things being sticky. Okay, here's an example of something we're all familiar with. Gum. Gum has a very weak polymer. It's very, we can see it's stretching apart. So gum on a sidewalk to shoe, we have a little intermingling, maybe a little entanglement, weak polymer, good dissipation of force across all of that material. And we have modest adhesion. Okay, now let's talk about sticky tape. So we stick the tape to a surface. Now we've got pretty good entanglement, pretty good intermingling. We maybe have a slightly stronger polymer, but it's not too strong. It still has some movement to it. And we end up with pretty strong adhesion. Okay, what about epoxy? I've got a threaded rod, got some epoxy on it. Well, what have I got? I've got a very tough polymer, right? It doesn't want to move. I have weak surface bond. I've got really good dissipation of force. I have diminished crack propagation here as well. Although with the right amount of speed, we'll talk about that later, I might end up with crack propagation. I have some mechanical interlocking that's doing some work there, and I have pretty strong adhesion. Okay, so crack propagation. Think about the release liner when you pull it off of one of your tapes. That silicone layer is acting a little bit like a liquid, and it doesn't have the ability to dissipate force. There's no intermingling, there's no entanglement, and so there is high crack propagation. So really, when we think about things releasing, what we want to think about is crack propagation. In fact, every time something doesn't adhere, really what it is a rate of crack propagation. What about a Teflon pan, right? Well, it's got this crystalline structure to it. So there's very little ability for entanglement or intermingling. There's a surface bond, but it's easy to break. And so again, we have the ability for rapid crack propagation. That egg doesn't stay stuck to the surface of that material. Okay, so we can sum it up in 7 basic rules. The first, everything is sticky. The second is that surface bond adhesion is necessary, but it's insufficient. The third is that intermingling creates a modestly strong surface. Think like 10x, right? But entanglement, we're at like 100x strength. So much, much stronger, much more useful adhesion. And that adhesion failure is always really crack propagation. And that dissipation of forces promoted by entanglement, intermingling is what prevents that crack propagation. And the last one is that the quality and force of the dissipation is a function of the chemical and the mechanical characteristics of the system's materials and the temperature and speed of force application. But the first 6 are the one that I want you to think about when we think about evaluating what is sticky and where we want to use it and when. Hope you enjoyed. Thanks, Foster.